Hello everyone. If you are following the Crypto Zombies series, then you know that we have completed 3 lessons of that Solidity path. In this series, we are going to explore the fourth lesson, which is Zombie Battle System. So let's start the course. So the time has come, human. Time to make your zombie fight. But zombie battle aren't for the faint of heart. In this lesson, we are going to be putting together a lot of concepts you have learned in previous chapters to build out a zombie battle function. We are also going to learn about payable functions and how to build T-apps that can accept money from players. So let's get started. Chapter number 1 is payable. Up until now, we have covered quite a few functions modifiers. It can be difficult to try to remember everything, so let's run through a quick review. We have a visibility modifier that control when and where the function can be called from. Private means it's only callable from the other function inside the contract. Internal is like private but can also called by a contracts that inherit from the one. External can only be called outside the contract, and finally public can call anywhere both internally and externally. We also have a state modifiers which tells us how the function interacts with the blockchain. View tells us that by running the function, no data will be saved. Change pure tells us that no, that's the function not save any data to the blockchain. But it also doesn't read any data from the blockchain. Both of these don't cost any gas to call if they are called externally from outside the contract, but they do cause gas if they call internally by another function. Then we have a custom modifiers which we learn in lesson number 3, only owner and above level. For example, for these we can define custom logic to determine how they affect a function. These modifiers can all be stacked together on a function definition as follows. So here it is: external, the visibility modifier, the state modifier, and the custom modifier. In this chapter, we are going to introduce one more function modifier, that is payable. The payable functions are part of what makes Solidity and Ethereum so cool. They are a special type of function that can receive Ether. Let that sink in for a minute. When you call an API function on a normal web server, you can't send US dollar along with your function call, nor can you send Bitcoin. For Ethereum, because both the money, Ether, the data transaction payload, and the contract code itself all live on Ethereum, it's possible for you to call a function and pay money to the contract at the same time. This allows for some really interesting logic, like require a certain payment to the contract in order to execute a function. Let's look at an example. His example is a smart contract online store, and is a function by something which modifier of external and payable. Check to make sure 0.001 ether was sent to the function call. There is a condition, and if so, some logic to transfer the digital item to the caller of the function. This is the function. This has some logic, and this is the address of the one who is calling this function. Here, message.value is a way to see how much ether was sent to the contract, and ether is a built-in unit. Ether is a built-in unit. Yes, it is. What happens here is that someone could call the function from web3.js from the df javascript front end as follows. Assuming online store points to your contract on Ethereum, online store dot buy something. That's how we can call it from the front end app. Notice the value field where the JavaScript function call specifies how much ether to send 0.001. If you think of a transaction like an envelope and the parameters you send to the function call are the contents of the letter you put inside, then adding a value is like a putting cash inside the envelope letter and the money get delivered together to the recipient. If a function is not marked payable and you try to send ether to it as above, the function will reject your transaction. Now let's put it together and do the test that provided by crypto zombies. Let's create a payable function in our zombie game. Let's say our game has a feature where user can pay ether to level up their zombies. The ether will get stored in the contract which you own. This is a simple example how you could make money on our games. How you make money on your games. Define a unit name. Define a unit name level up and set it equal to 0.001. Okay, now let's see. Unit level up fee and set it 0.001 ether. Okay, now create a function name level up. It takes two parameter unit underscore zombie id comma sorry one is just take one parameter and should be external and payable. Yes, the function should require that message value is equal to level up fee. Require message dot value is equal to level up fee. It should then increment the zombie level zombies underscore zombie id dot level plus plus. So I think that's it. Now let's check the answer. Yes, it's correct. So we have just created a function with the payable modifier. So let's move on to the next chapter.